Alright, we're beginning week 2 of systems. It's time to learn a new method of solving. Remember, in the beginning of last week we talked about how there were 3 different methods to solve. We spent last week on graphing. This week we are going to be looking at solving with substitution. Before we begin, we need to go back and review what substitution means in the context of math. So right now I want you to pause the video and write down a definition on your guided note sheet of what you think, or how would you explain substitution to a friend if they asked you. Okay, pause the video, write down your quick definition of substitution. Okay, when we substitute in math, we replace one expression with another of equal value, or we replace one expression or term with another expression or term that is the same quantity. So we could just write replace one expression with another expression of equal value. Okay? We're going to look at an example of substitution. And we're going to look at it in a very simple context, because before we start using substitution in systems, it's really important that you have your head around what I mean when I say substitute. So we're going to start with something simple. Let's say I tell you x equals 7. And I give you something like 3x equals 21. You can tell me, you can plug in this 7 for x, right, and still have a true statement. So I'm going to change the color of what I'm substituting in so you can see where I'm taking this x out and I'm putting in a 7. It's a different way of writing the exact same quantity. The key thing is I do not change the validity of the statement. 3 times 7 is 21. That is still, the left is the same as the right. 3 times x would be 21, 3 times 7 would be 21, 21 is 21. This is 3 different ways right here of writing the same quantity. Okay? Let's try something else. Let's look at this expression. If I have 3 times 5 equals 15. There's nothing abstract about this one, no variables, but it's something you know is true, right? 3 times 5 or 15, it's the same quantity. It's 2 different ways of writing the same thing. When we substitute equal quantities, a true statement will remain true. We use substitution to simplify or solve problems. Our whole purpose in substituting is going to be to make it easier to solve. Remember, we're going to do as little work as possible and get the right answer. Okay? So if I want to substitute here, try and think of it. Can you think of a different way to write 5? That's 5, right? So I'm going to take this 5 out and I'm going to substitute in the same quantity written a different way. So then it would be 3 times 3 plus 2 equals 15, right? So whether I distribute and say 3 times 3 and 3 times 2 and put 9 plus 6 is still 15, or I can combine like terms and I still have 3 plus 5. The bottom line is I substituted in the same quantity written differently, and I did not change the validity of the statement. The left is still equal to the right. Now in this one we're not going to make that substitution because it makes it more complicated. But if I said, here, simplify this, and I didn't put, let's pretend that's not there. Let's just say 3 times this, solve it. What are you going to do? First thing you're going to do is take that 3 plus 2 out, and you're going to say, oh, 3 times 5 is 15, right? You didn't realize it, but when you took that 3 plus 2 out maybe, and you combine the terms to make it 3 times 5, that's substitution. Now, that's what we're going to be doing to solve systems, and there's variables, and it looks more complicated, but it's not. It's take one expression out and replace it with an equal expression that makes the problem easy to solve. All right, I think that we're ready to go ahead and look at an example of a system. So we're going to have y equals 2x plus 1, and we're going to have 3x plus y equals -9. So there are two variables. So it's not like I can solve for y and get a constant answer because I got that x there, and I can't solve for x because there's a y. So we can't solve it the way we have in first quarter. So if you look at the system and consider using substitution to create an equation with only one variable, you want it to either have all x's or all y's. Can you think of an equal quantity that you could use to substitute or replace one term with another to make one of these equations solvable? Keep in mind, when substituting, we can only use equal quantities to replace an expression or term. All right, do you see another way to express the quantity y? I can replace y with 2x plus 1. I can pull that y out because this equation here tells me y is the same as 2x plus 1. Whatever this quantity is, this is the exact same quantity. So I can take that y out and I can put it in, I can take this y out and put this expression in. So that would give me, I'd still have the 3x plus, and I'll still have the equals -9. But when I take that y out, I'm going to put in 2x plus 1. I use parentheses because if there's it can keep the signs and everything straight for me so I don't mess up later when they get more complicated. But there's a 1 here to distribute, so really what I end up with is 3x plus 2x plus 1 equals -9. Do you see how I can solve that now? I can combine like terms. 3x plus 2x is 5x. Again, when I take those out and put that in, substitution. Plus 1 equals -9. And I now have an equation like we're comfortable with, not only from first quarter, but you did this in 8th grade and before. So I'm going to subtract 1, oopsie, sorry about that. I'm going to subtract 1 from both sides, and I get 5x equals -10. Keep it an eye. -9 minus 1 is -10. You got to watch those signs. I divide both sides by 5, and I get x equals -2. Now that's not enough. I have x equals -2, but my system, I need a value for x and y for my solution. So let's take and think about how we could do that. I know x is -2, and I know that y equals 2 times x plus 1. Well, now I know what x is. So I can take that out and put a -2 there, right? So y is 2 times x plus 1. 2 times -2 is -4, plus 1 is -3. And the answer to this solution, x is -2, y is -3. Now, in class tomorrow, we're going to talk about the importance of and how to check the solution, but I didn't want to do that on the video tonight. You ready to try another one? Make sure you're getting all of this on your notes. All right, here's our next system. Okay, so we have x plus 2y equals 6 and 3x minus 4y equals 28. Do you notice anything different about this system than the example that we just did? Okay, when you look at the system, there is no expression where you have a variable by itself giving you an equal expression to substitute in. You don't have x equals 3y plus 2. So in this situation, we have to manipulate the equations so to create an expression that we can substitute in for one of the variables. Okay, so I am going to take the expression, the first equation here, x plus 2y equals 6, and I am going to isolate the x. I'm going to take and get this x to be by itself, so I have an expression that's equal to x. So I'm going to subtract 2y from both sides, and that's going to give me a new expression, x equals negative 2y plus 6. Okay, that right there, same line if I graphed it, just written a different way. And it's written in a way that helps me because now I have an expression equal to x. In terms of y, I'm going to replace this x right here. I'm going to substitute in this expression for x, which is equal. So I'm going to have 3, and I'm going to leave an opening, minus 4y equals 28. This is where I need to substitute something in. And what I'm going to substitute in, instead of x, I'm going to write negative 2y plus 6. And my reason for doing that, remember, I now have an equation with one variable in it. It looks like the equations that we solved first quarter. So in order to solve now for y, I'm just going to distribute, combine like terms, and solve. And I want you to do that on your paper right now. I want you to try and simplify and solve that equation. Okay, did you get what I got? If you're still working, pause the video. Work it out and then compare your work to mine. Alright, we have our y. We still need our x. Remember how we got our x. We take what we know is y and we substitute it in. When you go back to these original equations to substitute in to find your second variable, select whichever equation looks easier. I'm thinking that I'm going to use this one. So to get my x, I'm going to say x plus 2 times what I know. I'm substituting in for y again. I know y is negative 1. It doesn't need to be a variable. It's not unknown anymore. Okay? So x plus 2 times negative 1 equals 6. So x minus 2 equals 6. I multiplied there. I add to both sides, and x equals 8. I now have my final solution, and that is how you solve systems by substitution. Okay, I hope you took good notes. If you didn't, go back and make sure you get them down. It's nice to be able to pause or rewind the lecture. You can't do that when we do these live in class. There are 2 problems for you to try in the guided notes, and they're due at the beginning of the class. It's really important you go ahead and try them and see how good your notes are. If you have problems, remember, write down or mark where you're having problems so we can discuss it in class tomorrow. Have a good night.